Hello and welcome to the project review of the AWS Smart Door. The primary objective of the AWS Smart Door project is to create a door that can be locked and unlocked using a variety of keys. The motivation behind this project is that physical keys are easy to misplace, difficult to find, and a burden to carry around, and the AWS Smart Door makes it easy to unlock the door from a variety of ways. The virtual keys that can be used to unlock the door are a button on the inside of the door, an Alexa skill, facial recognition, voice passphrase recognition, and a smartphone application that connects to the internet. The AWS Smart Door was made from a simple electric door lock and other hardware peripherals that are incorporated into a smart system via Amazon Web Services. Furthermore, features of the system can be controlled by the user on a smartphone app or an Alexa device.
Now, Ben is going to walk through the hardware subsystem and all of its components.
We have the Raspberry Pi as our main computing unit. The Raspberry Pi responds to signals from both AWS and various hardware devices connected on the Pi's input-output pins. Of these devices, we have a button on the inside that will unlock the door immediately. We have another button on the outside of the door that turns on an LED that indicates that the user can say a password to unlock the door. We have a door contact sensor read switch that indicates whether the door is open or closed. Finally, we have a motion detector that detects infrared motion from 6 feet away in a 160-degree range. The Raspberry Pi also controls other hardware devices that make the door operable. The speaker and microphone are USB connected to the Pi that play and record audio files. We are using a PlayStation Eye as the microphone input. We are using the camera module built for Raspberry Pi to record video. The door lock is controlled by an Arduino that responds to serial commands from the Raspberry Pi. The lock solenoid needs 1.5 amps to unlock, so we are using a second power adapter to power the lock and a relay to control when it receives power from a signal from the Arduino. The power is supplied from an uninterrupted power supply that will hold a charge for around 8 hours.
Next up, Giovanni is going to go over a simple diagram of the user interaction subsystem.
So this is a quick overview of how the user interacts with the door. So we'll start with the inside of the door. So there'll be 3 ways to open it. So with the voice command, you'll either be able to say lock or unlock the door, and the door will unlock depending on what you say. There's also a push button. So if you press the button, the door will unlock. There'll also be an app you'll be able to use. So there'll be a command on the app that will allow you to lock or unlock the door. It will lock or unlock depending on what you press. And then from the outside, same thing with the app. You'll be able to also use those commands to lock or unlock the door. There'll also be a button that you'll be able to press. So you press the button, it'll prompt you to, it will start recording audio. So it'll prompt you to say a passphrase. If the passphrase is correct, the door will unlock. Also, since you're in front of the door, the motion detector will trigger and it will start the camera. So then it will start scanning your face. If your face is authorized, the door will unlock. Keep in mind, you don't have to necessarily manually lock the door within these methods because the door will automatically lock after a couple seconds.
Now that we've seen how the hardware and the user interact with each other, I'm going to go over the AWS subsystem diagram along with a few video demonstrations. The first feature we're going to go over today is facial recognition. Facial recognition is achieved whenever a user steps in front of the door outside, triggering the motion detector, which then turns on the camera and starts a live stream using Kinesis video streams. This stream is then ingested by Amazon Recognition, which performs facial analysis by querying against other faces found in an Amazon DynamoDB table. If a face is found, these results are then passed back to a Lambda function, which then triggers the door to unlock and greets the user by name. So I'll go ahead and trigger the motion detector, see my face.
Welcome home, Josh. The door is unlocked.
This feature also works even if there are other faces in the frame that are not recognized by recognition.
This is a demonstration that the facial recognition will not work because my face is not in the system.
And now we'll demonstrate that I'll come in and step behind Jennifer and it will recognize my face behind hers.
Welcome home, Josh. The door is unlocked.
Another important feature of this project was passphrase recognition. This is achieved by pressing a button on the outside of the door, which turns on an LED and microphone for 5 seconds that records audio. This audio is then converted into text using Google's speech recognition API and sent to an S3 bucket. Submission to this S3 bucket triggers a Lambda function, which takes the contents of the text file and compares it to our passphrase table in DynamoDB. If there is a match, the door will then unlock via an MQTT message from Lambda.
This is a demonstration that doing the correct passphrase will unlock the door. So go here and record some audio. Senior design.
The door is now unlocked.
The demonstration of a passphrase that is incorrect, so it will not unlock the door. Incorrect passphrase.
That passphrase is incorrect.
Another method of unlocking the smart door is through our mobile application. All that this does is makes a simple API call to Amazon API Gateway, which then triggers a Lambda function that unlocks the door via MQTT.
Okay, so this is a demonstration on how to unlock and lock the door via the app.
So we're going to go into that feature right here. So we're going to unlock the door.
The door is now unlocked.
And then we will lock the door.
The door is now locked.
The door can also be unlocked with an Amazon Echo device coupled with a custom Alexa skill we built that triggers a Lambda function to unlock the door.
Unlock door.
The door is now unlocked.
The door is unlocked.
Lock door.
The door is now locked.
The easiest way to unlock the door is through a button placed on the inside. This does also not require any active internet connection.
The door is now unlocked.
Our door also features a couple of safety features, such as not being able to lock whenever the door is open.
And then I'm going to lock the door and then give a message saying that it's going to lock.
The door must be closed to be locked.
Perhaps the most important safety feature of this door is its ability to automatically lock when the door is closed, or to lock after 10 seconds of not being opened.
The door is now unlocked. The door is now locked.
The final safety feature of our door is its ability to notify the user via text or email that the door has been forced open while not being unlocked. The door will also notify the user if it has remained open for too long.
Okay, so this is a demonstration of the door being forced open while it's already locked.
The door has been forced open.
This is a demonstration of how the door will notify the user when it has been open for too long.
Please close the door.
Here is the resulting email from our door being forced open. Another important feature of our door is to view both live streams and access log videos. Amazon Kinesis video streams automatically saves each live stream for up to 24 hours. However, when a live stream ends, we export the video file to an S3 bucket. This S3 bucket is linked with a DynamoDB table containing timestamps of when the door was in use.
Okay, so this is a demonstration of how you can view access logs from the app. So as you can see here, this is the various times the door has been locked or unlocked. It goes all the way back to the past couple weeks, so it's plenty of access logs to access. So you can look here, the last video that has been taken. Every time the door has been unlocked or locked, it takes a clip. So this is the last time it's been triggered. Okay, so this is a demo of how you can view a live stream from the app. So I'm going to start the stream, and then I'm going to view it. So as you can see, there's no one in front of the door. And then there's Jennifer right there. Okay.
That concludes the demo, so now I'm going to go over some of the strengths and weaknesses of our smart door. The biggest strength of our door is the use of multiple virtual keys that can be used to unlock. These keys include an Alexa device, a push button on the inside, facial recognition, passphrase recognition, and via the smartphone app. Another strength is the ability to see exactly when and how your door was used. It will also remain functional even if external power is lost because of our uninterruptible power supply. This can power the door for up to 8 hours after power is lost. Finally, the door has the ability to greet the user by name if their face is detected. This is nice because it can be integrated into other smart home features if you have them. Now to go over some of the weaknesses of our project. The biggest weakness is no Bluetooth connection through the app. This is not good because if the door goes offline, it is completely unusable from the outside. Also, since this project was a prototype, it is not connected how it would be on a real door. One of the features we wanted when designing this project was two-way communication with the door. This proved to not be possible due to a 4 to 5 second delay of the live stream on the mobile app. Finally, facial recognition will not work if it is dark outside, and another key must be used to enter. Alright, and that concludes this video. Thank you for watching if you made it this far, and I would just like to give special thanks to Dr. Groff and his TAs, Clemson University, and our senior design team, as this wouldn't have been possible without any of them.